Good morning, everyone. I am Kim, founder and CEO of Captis Aire, and very happy to be here this morning. We provide an advanced industrial air pollution control technology that cleans the air from wood products manufacturing facilities. And I have over 34 years of experience in the wood products manufacturing business. So that's how I know that this technology that I'm going to share with you today is very valuable. So here's the problem. When wood products are manufactured, one of the first steps in the process is to dry the wood. And when you dry the wood, you're driving off not only all of that water, but also the organics in the wood. And when these organics are released, they actually become air pollutants. And these air pollutants must be controlled with an air pollution control device. Today, these huge devices that you see in the picture here, called oxidizers, they control these pollutants by burning them. And in the process, they use huge amounts of natural gas. In fact, they use so much natural gas that we actually refer to these things as gas guzzlers. And when these gas guzzlers burn this huge amount of natural gas, not only does that create greenhouse gases, but also, as you can imagine, it's very expensive to operate. And especially in today's world, with the cost of natural gas skyrocketing the way that it is, you can imagine these devices are becoming more and more and more expensive for our customers to run. And this is the natural gas that our technology can reduce or even eliminate. So the alternative is to very efficiently capture and recover over 90% of these pollutants, which in the case of drying green pine wood are actually composed primarily of valuable turpentine. Capturing this material enables our customers to recover and sell this valuable turpentine, as well as reduce energy use, especially natural gas, and reduce greenhouse gases. And the good news for our company is that we can literally sell these devices to hundreds of sites. With Oak Ridge National Lab and Innovation Crossroads, we have both the ability and the opportunity to get rid of these gas guzzler oxidizers and instead replace them with our energy efficient capture technology that could provide all of the following benefits. And when commercialized at just 50 sites, could enable us to drive down energy usage by over 10 trillion BTUs per year, enable our customers to reduce their operating costs by up to $150 million a year, enable our customers to recover and sell 10 to 15 million gallons per year of this valuable turpentine, and address the climate crisis by reducing greenhouse gases. Last but not least, we have a great team. Our team has already successfully demonstrated this technology at a commercial wood products manufacturing facility where we were online for 6 months. In fact, during that time, we actually collected this beautiful, valuable turpentine. As you can see here, the sample is beautiful, clear, colorless, and it smells, I'll share it with you too. It smells a little like a pine tree, as you would expect. Yes. So I'm also very proud to say that right now we're talking with one of the world's largest forest and forest products producers about implementing this technology at their site, primarily to reduce greenhouse gases. Today's air pollution control devices, unfortunately, are gas guzzlers. We're fixing that. Thank you so much for your time, and I hope you reach out to me to learn more. Thank you.
Anyone have questions?
She's coming behind you.
34 years.
Oh, yeah. So I had a variety of roles. I was a chemist initially, and I progressed to like group leader, senior technology scout, and also project manager. So I did a variety of roles. We were in R&D, primarily working in wood products, like making particle board, oriented strand board, plywood, those kind of things.
Seems like this would work well for a chip burner plant as well, because we dry the chip before we burn it for
Yeah,
power.
right.
But
right.
I was wondering, is it a catalyst type process or?
Yeah, no, that's a great question. So we actually use activated carbon. So activated carbon, just like you probably use at home in your drinking water to clean your drinking water, like in your refrigerator. Activated carbon cleans the air. It acts like a sponge. It like soaks up those organics out of the air.
Then you can strip those.
Yes, yes, yes.
Is it exothermic?
No, just very slightly.
How about the capital cost to install this compared to a gas guzzler? The footprint, is it about the same size? Is it smaller, less expensive, more expensive?
So we have some advantages in terms of size and weight. It's significantly less heavy than standard gas guzzler, the oxidizer. It's smaller or comparable in terms of footprint, and it's comparable in terms of capital costs. So really, once somebody needs to buy a new device for whatever reason, either because theirs is worn out or they are expanding production or whatever, that's when we're really, really competitive. Because if we can offer our technology at roughly the same price as the gas guzzler, then they get all these other benefits, then it really becomes a no-brainer. Great question.
Fascinating technology, but we need to keep moving on. We can talk. Go please. Couple more.
So you said that 90% efficient, does that mean we're inside regulatory limits, or is there a downstream treatment that needs to be made?
No, so the PCWP MACT is the applicable regulatory standard, and it requires 90% reduction efficiency. So we meet that. That was an important learning from our demonstration.
Thank you.
Yeah. It's mostly electrical.
Okay. Thank you. Fascinating technology.